Good day, everyone. You're all welcome to today's class. Hopefully, it will be our last class. So we have two topics left from our course outline. We have the multinomial logistic regression and the ordinal logistic regression. I believe in our previous class, I explained the difference. I told you we have three types that we'll be discussing in this class, three types of logistic regressions: binary logistic regression, multinomial logistic regression, and ordinal logistic regression. Now, for logistic regression, the dependent variables are categorical variables, string variables, they have characters, qualitative. I've tried to use different words for you to understand it. When we talk about ordinary least square regression, the dependent variables are quantitative, they are numbers. But for logistic, the dependent variable is a categorical, qualitative, string, character variable. So now we've talked about binary logistic. For binary logistic, it has only two levels: yes, no, boy, girl. So then we are going to, when it has more than two levels, it can either be ordinal or multinomial. Now, the difference between ordinal and multinomial, if you can order the levels, you know it's ordinal logistic. For example, you're talking about rank of lecturers, rank of police officers, grade in a course. You know you can rank A, B, C, D, E, F. You can also rank second class. So all this I've mentioned that for ordinal regression. About the courses you offer in your school. We'll talk about your best colors. We'll talk about your where you deliver your baby. Deliver your baby at home. You can't order them. Where you can order them is multinomial. So we are going to start with the multinomial logistic regression. So briefly, let me share my screen. So we'll continue. So we have a work here. So this is the data we're going to use. Now, the dependent variable here is place of delivery. Now, let me explain briefly about this data. This data is about place of delivery. So now they want to do a research work. What's the research work? They want to know the factors that influence people's choice of place of delivery. Now they want to know if region, education, religion, wealth, insurance, and the birth order have any influence on people's choice of place of delivery. So this is a research work. You know, normal, like I've told you, yeah, a data doctor, and the essence of everything is for you to help in decision making. You give conclusion, and that conclusion will help in decision making. You are supposed to make recommendation that policies makers will use for decision making. So now, if we can know the factors that influence the place of delivery, now the essence of this work is to discourage people from delivering their baby at home. That's the essence of this work. So we want to know, though we have three for the dependent variable, which is place of delivery. We have three levels. We have home, we have private hospitals, and also have private hospitals. Are you seeing it? So that's why it's the multinomial logistic. You can't order them. So the essence of this work is to discourage people from not giving birth to their baby at home. So we want to know, when we know the factors that can make people to give birth at home, we can now make recommendations to policymakers that these are the factors that influence positively women's choice of delivering their baby at home. So now they know how they can play with those factors and try to reduce the number of people that give birth at home. So either they educate them, they look for those set of people that the research will point at. If it's money that they need it because of jobs. So they just look for a way to So this will lead to a targeted solution to our problem. So we look for those people and provide solutions. So the essence of everything is to make recommendation. So now, one thing that you have to do is, this your dependent variable will always have a reference level. I've been talking about reference level from binary logistics. We have a reference level. Now, the reference level, one of it will be used as reference level. Then the other levels will be compared to it. So assume, like, because our interest is on ohm, we use ohm as our reference level. Then we'll compare government and ohm. Then we'll also compare private and ohm. If you watch both, the other two levels are compared with the reference level, which is ohm. Why are we using ohm as our reference level? We're using ohm as our reference level because that's the factor, that's the level we are interested in, to discourage people, to know the factors that influences people to give better to. So the number for ohm here is 2. So I've taught you how to use this. Well, after coding, if you want to see it, you use this symbol. So I believe I've explained. So we go to multinomial logistics. Remove your dependent variable, which is place of delivery. Remove it. Then the others. Now take note of this. We have two dialog boxes. The first is factor, the next is covariate. For factor, we'll move. I think we'll move, let's see. Then we'll move the quantitative to covariate. Let me see something if I explain, so that I will not explain something. Okay, so we are correct. A minute. Okay, we are correct. So I just wanted to check before I explain. So what I did, let me reset it. So you move your dependent variable, place of delivery. Then you move your quantitative. Quantitative means numbers, and the only quantitative data we have here is birth order. You move it to covariate. Then all the qualitative, categorical, you move them to what? Factors. So that's how it is. Then you choose your reference level. Remember, I told you your reference level is very important. Reference level is very important. Your dependent variable, like I told you, we are using ohm. Ohm is our reference level. Then you go back to, if you want to know if it's the first or the last, that's why I checked the number earlier. I have to go from here. So look at it. If you want to know if it is first or last, look at it. Ohm is 2, so that means ohm is last. 2 is last. Remember, if you want to, ohm is our variable of interest, and it's 2, so it means we are going to choose last. So let's go back. Analyze regression, multinomial regression. So for reference, we are going to 0. That means when we are coding it, we use 0. Then we'll change it to first. So now we are going to use last. You also category order. So we're talking about in ascending order. So in ascending order, it means we are going 0, 1, 2. That means last. But if you go for the descending order, we go to first. Very simple. Then we'll go to statistics. We can select our goodness of fit. That's all. Continue. We'll go to option. We'll go to save. Continue. Then okay. So you have this. So this is your descriptive statistics. Frequency table, talking about the frequency and percentage. Normally, I used to delete this, the last part. I used to delete this. Normally, the SPSS will tell you if you have missing values or not. So what I normally do is I delete this, then I will change this value to total. Since I already know that there is no missing value, correct. So I will change this. I will delete all this and change this to total. Your choice. You must not follow me. Your choice. So I will explain all this briefly. Now, this is used to know if the model is a good model. So we use it for goodness of fit of the model. I've been explaining goodness of fit of the model in our previous classes. So this is for goodness of fit of the model. So it's comparing the intercept only model and the final model when you've added all the coefficients. This was also explained in a binary logistics. So for the intercept only, the model has only the model has the intercept and the variables. Now, why are we comparing them? We want to know if after you added the variables in the second final model, after adding all the independent variables, when I talk about independent variables, I'm talking about our variable of interest here, which are what? Region, residence, education, religion, wealth, insurance, bet order. So these are our independent variables. So I don't need to come back to this. Whenever I say independent variables, you know what I'm talking about. Whenever I say dependent variable, you know I'm talking about what? Delivery. So now the first model has only the intercept. That means it has none of the independent variables. The second model, which is the final model, has both the intercept and the independent variables. Now, we are trying to study factors that influence people. Consider different factors. What if the factors we considered have no significant effect in the people's choice of place of delivery? That means it doesn't affect their choice of place of delivery. So that's what we are trying to test. Now, this first model has none of the variables. The last model has all the variables. So we want to check the two models, are they performing similar or are they performing differently? This was explained in detail in our last video on binary logistic regression. So we want this p-value, that is significance value, which is the p-value, to be less than 0.05 or alpha level. So that when you less than, it means that the final model is better than the intercept model. So it means the model is a good fit and the variables are predicting, can be used to predict people's choice of place of delivery. This is also used for goodness of fit. This is also used for goodness of fit. This pseudo arrow square is like, I will show you a detailed explanation. This pseudo arrow square is trying to mimic, is trying to mimic the OLS arrow square, like the name pseudo, you know. It's not really the OLS arrow square, but it's trying to mimic it and has almost similar explanation. This table, the first table, the second table, and third table are all used for goodness of fit. So we'll check this model. Can we use it to make a decision? Can we use it to make a conclusion? Or should we just stop? Is it really proper? Then this other table is used to know now, well, I've been trying to explain this. It's possible that in a class, you can say this class performed well. Even though they performed well, there may be one student that they performed well. But because majority performed well, you can give a general statement for that class that they performed well. You can also have a football team and say this is the best team in the world. Though they are the best team in the world, they still have players that are below average. Now, with these three tests, model fitting information and goodness of fit can tell us that the model is a good one and can be used to model people's choice of place of delivery. But that doesn't mean all the variables may be significant. It means maybe 7 of the variables are significant, then 1 is insignificant. But even though it is insignificant, because it was used together with all the other variables that are significant, it will not really affect the performance of the model, or it will affect it maybe little, but it won't really show. So that's what is the first test, that just to tell us if generally all the variables, the model is a good fit. Then this likelihood ratio test will now pick each of them to tell us, well, let's study each of them and know the ones that really performed well. So we want the p-value to be less than the level of significance, depending on what you're using as a level of significance. For this work, we're going to use 0.05. So using 0.05, we can see that all the variables here are less than 0.05. It means we can use bet order to predict people's choice of place of delivery. We can use insurance, we can use education, we can use region, we can use religion, we can use residence, and we can also use wealth. So very simple. So it means all the variables. So since all the variables are significant, I can now interpret. Now, you have to interpret this one after the other. Normally, what I do is I cut this table. I will cut this table. I will paste only the first part that has to do with hospital. Then I will paste the second part, the private hospital. Then I will paste the second part that has to do with government hospital. Remember, I told you we selected home as our reference level. So what are we doing? We're comparing private and home. We'll make our decision. Then we'll also compare government and home. There's no we are not going to compare private hospital and government hospital because we didn't use any of them as our reference level. So we are going to compare the other levels to the reference level. So there's no comparison between government and hospital because that's not our focus in this research. Our focus is we are trying to look for the factors that's this problem. People give birth at home and it has many disadvantages. So we're trying to look for a way to reduce the number of people that will give birth at home. So that's what we're trying to do. So that's why our variable of interest, level of interest is home. So remember I told you first, we've already checked for the significance of the variable. So we don't need to check for, okay, we can still check for it. But we know that all the variables are significant, then we'll have to make our interpretation. So what I'm going to use to make our interpretation, we're going to use the exponent of B. Exponent of B is very important. Exponent of B is very important. Then we're going to use our words, B. So it's the same way with the last explanation when I did almost the same with binary logistics. So let me show you the results here and how it was interpreted. So I just give it, so the independent variable for this analysis, the place of delivery has 3 categories, which are this, and this. So this is just a brief description of the data used for this study. Talked about the independent variables. We have 7 independent variables and I stated them. Then I stated that the descriptive statistics given below, which you all saw from our analysis. Okay. SPSS didn't give us this the provision to test for this assumption. We call it the generalized variance inflation factor. Now, what people normally do, some researchers do, they use the VIF, which I explained in our last class. They use the VIF, but they only use the VIF when they have more than one quantitative data in the independent variable. In this work, we only have one quantitative data in the independent variable. So when they have a case like that, they forget about testing for multicollinearity assumption. They only test for multicollinearity assumption when they have more than one qualitative data. Now, other people have researched that can't they get another method that can be used for categorical data? They can use it to test for multicollinearity for both qualitative and quantitative data. So they came up with this generalized variance inflation factor. Now, sometimes when I do work for people, I just use the first group, the first research from the first group that work with only the variance inflation factor for quantitative data. But for this work, I use the generalized variance inflation factor. Now, SPSS cannot do this. I didn't use SPSS to do this. So that means I used ARU programming to do this. So I'm not teaching you ARU. So we are going to assume this is not in this work. If you want to learn it, just go online and search generalized variance inflation factor for ARU. So you search generalized variance inflation factor for ARU. So this is the code. This is the code for it. So you can see it. So it was the code I used. I used arrow for it. So let's go back. So I'm going to assume this is, we are working with the first school of thought. Since we only have one quantitative data, we're not going to test for it. If you want to go with the second school of thought, which I did here, generalized variance inflation factor, you can use it, but use arrow to do it. But for this work, because I'm teaching you only SPSS and Minitab, so we assume like the way we did for binary logistics. So we'll just say because we have only one quantitative data, we can't test for multicollinearity, then we move ahead. Or you just maybe don't say anything about it, just say you have only one. Okay, you can still state it. Then the next thing is, which I've shown you this table where we compare the intercept only and the final model. So the coefficient of the model are statistically significant. The variables added So look at it, improve the model. Remember I told you I'll check if the variables added improve the model when compared to when the variables were not in the model. So like I told you, we want the p-value to be less than 0.05. I've taught you how to interpret. We also use the pseudo arrow square to know the percentage variation of the dependent variable that can be explained. So in this work, we have 3 types of pseudo arrow square. Now, different researchers propose different pseudo arrow square. So the one I mostly use is the name that starts with N. Pronouncing it is difficult, so you can pronounce it. So looking at it, it means the gauge is 0.46 pseudo arrow square. Some people ignore it because of that name, pseudo arrow square. They feel they should just consider, they should just use the model fitting information table and use it to know if the model is stable. They say little or nothing about the pseudo arrow square, your choice. So we also tested, like I've told you this, to test for the model is significant. Now let's do a test for each of the variables, and each of the variables is also significant. So all the variables are statistically significant because their p-values in table 4.5 are all less than 0.05. So now, since they are all significant, it means I can now interpret. Okay, take note, we are using alpha 0.01. That's what I use for this work. So now let me explain how to interpret the table. Remember, I told you that I'm going to split the table, which I did here. So I had to split the table, this for private hospital. Then after interpreting it, I then copy the other table for government hospital. Now, how did I do this? What I would look at how I got this. I've taught you, double click it. You come to this place, you highlight and delete. You highlight and delete. Now, if you want to get for since you delete, when you delete, you copy and paste to your Word. Then if you want to get for government, you have to repeat the same analysis so that you can get the table that will contain both private and government hospital. Then you highlight private and delete. So that's how I was able to get both tables. I was able to split both tables. Now it's good like this so that I can get the first table, interpret, then get the second table and interpret. It will be very easy and make my work easy to understand. So now let's learn how to interpret this. Now the last one we learned about binary logistics. There are some things I could not explain, but I think with this work I will explain most of the things about logistic regression. Now, the way they interpret take note, the way they interpret quantitative variable is different from the way they interpret qualitative variable. When I talk about quantitative, I talk about numbers. When I talk about qualitative, I'm talking about categories. I mean, variables that have categories. Insurance, yes, no, it has categories. But when we are talking about bet order has no category. They are all numbers, numerical values. So the way they interpret numerical values is different from the way they interpret categorical values. So now let's interpret this. The significance. So look at this. Take note of the B. The B here is what? Because it's negative. Negative means it's decreasing. Negative means it's decreasing. Then if here is, if you want to use exponent of B, if exponent of B is less than 1, it means it's decreasing. So now how do you interpret this? Let's see. Look at, take note of that one. So you say a unit increase in bet order. We'll be using the exponent of B. We'll be using the exponent of B again to interpret. Now, how do you interpret this? If you want to use exponent of B, I taught you, since this what I taught in binary logistics, because it's less than 1, you do 1 minus. When you do 1 minus this, you get 0.052. Then you multiply by 100 to convert to percentage. So what you have is 5.20. So interpreting this, I would say for every 1 unit increase in bet order, remember we are comparing private and home. The odds of women choosing private hospital to home is 0.948. Let me say it again. For 1 unit increase in bet order, the odds of women choosing private hospital to home is 0.948. Now I've interpreted this based on what? Odds. Based on odds. So now let me interpret it based on the likelihood method. Well, let me interpret this now based on the likelihood pattern. Now for the likelihood pattern, that's what we use the percentage. Then remember, you know that it's decreasing. Why is it decreasing? Because of what? It's negative for the number for B is negative, and this is also less than 1. So if you want to use the likelihood pattern to interpret, you have to get the percentage. The percentage here is you do 1 minus 0.948, which is 0.052, multiply by 100 to convert to a percentage, you get 5.2%. Then you say for 1 unit increase in birth order, this is how to interpret quantitative. For every 1 unit increase in birth order, women, the likelihood that for every 1 unit increase in, let me see what I used there, so I will not say that. So for every unit increase in birth order, a unit increase in birth order decreases the relative risk of preferring private hospital to home by, so this relative risk is the same thing as odds. So you are interpreting it based on relative risks or odds. So a unit increase in birth order will decrease the relative risks of preferring private hospitals to home by 0.948, given that all other variables in the model are held constant. Now you have to, since we are interpreting each of the variables one after the other, so all the other variables must be held constant for you to interpret the other one. So you must state that condition. So now, first you have to interpret it based on what I told you, based on their odds. Another name for odds is what? Relative risks. Then if you want to interpret it based on the likelihood pattern, you know, so this means that, so now why you have to do the second way, why I do it is not compulsory. Using the relative risks or the odds method to interpret it may not really be easy for people to understand. Maybe for statisticians, they can understand it. They know that when the odds is less than 1, they know that it's decreasing. But people prefer using the likelihood pattern to interpret. Why? Because they can easily understand it. So that's why I continue interpreting it. So I say this means that a woman is 5.2% less likely to prefer home over private hospital for every unit increase in birth order. Now take note. Why is it less likely? Because of what? It is less than 1. This is less than 1. And the coefficient of B is negative. So that's why it's less likely. So that means, remember I've told you, you subtract 1 from this to get 0.052. Okay, sorry for that. I was trying to correct something. Let's continue sharing. Now, please take note of this. I don't know, this is surely a mistake. Remember, I told you that we are comparing, our reference level is home. So we are comparing private to home, and we are comparing government hospital to home. So the interpretation should always be private to home. So this was to be private hospitals. Now, you only talk about home first when you take the inverse. Like in our last class, I taught you how to take the inverse, and I told you when to take the inverse. Now, when do you take the inverse? You take the inverse when the exponent of B value is so high, maybe more than 2. You take the inverse, right? And convert it to a value that will be less than 1. If it is 1 point, it's okay. But when it's more than 2, I prefer to take the inverse. When I take the inverse, that's when I can now say home over private hospital. But since we didn't take any inverse, it will always be private over home. So I've already explained. So every other thing remains the same. So for every 1 unit increase, in birth order, a unit increase in birth order, or say for every 1 unit increase in birth order, the relative risk of preferring private hospital to home, so what is correct here. The relative risk of preferring private hospital to home decreases by, so look at the decreases by 0.948. Why is it decreasing? Because of that negative sign and because this value is less than 1. So you're interpreting it based on the likelihood method. So you say that means that a woman is 5.2% less likely to prefer home hospital, to prefer private hospital over home delivery for every unit increase in birth order. Now let me explain this. What is birth order? Birth order means, is it your first child you are giving birth to? Is it your second child? Is it your third child? So it means this a unit increase means once a woman gives birth the first time, if she wants to give birth the second time, now the possibility for her going to a private hospital over home will reduce. That means maybe at her first birth, she will likely go to a private hospital. But when she wants to, as the birth order is increasing, her second child, she may still go to a private hospital, but maybe she may be tempted to deliver at home. When the birth order increases again, the likelihood of her going to private hospital will still decrease. Then you discover that maybe her last child, she will not deliver at home. Now, why is it? So that's the essence of this work. This work is to expose and to tell us the factors that influence it. So we discover that birth order can influence women's choice of place of delivery. So what will you propose? Remember, statistics for decision making. You tell them that they should now target people that have given birth already and tell them that because their first delivery or their past deliveries were successful, that doesn't mean they should think they understand everything about birth delivery and they should become complacent that they want to deliver at home. So you start suggesting to them that, and giving, maybe you also give them statistics of women that are like them with higher birth order that try to deliver at home and they have complication. You tell them that if they try to deliver at home and they have complication, how will they resolve it? But if they were in the hospital, they can take care of emergency cases. So you try to tell them that increase in birth order should not be a good reason for them to choose home over private hospital. So from this work, it has shown that they are less likely to prefer private hospital over home, and that's given us the percentage. That means as when they give birth the first time, the percentage of them giving birth in a private hospital again will decrease by 5.2. So let's continue interpreting. That's how to interpret. So when you want to interpret quantitative, you talk about a unit increase, a unit increase, a unit increase in the birth order. What will it result to? It will either decrease the relative risk or decrease the odds. So a unit increase, that's how to interpret it. Now, how do we interpret qualitative? To interpret qualitative, you compare the different levels. You compare. Remember, we are still comparing the levels of the dependent variable. Then you also compare the levels of the independent variable. Now, for insurance, we have two levels. We have no and we have yes. We have no and we have yes. So we also compare it. We have no and we have yes. So now this work is using yes as my reference level. So that means we are comparing no against yes. So now you talk about the odds ratio, or sorry, the odds, and that which we can also call it the relative risk. So that means the relative risk of women with no insurance preferring private hospital to home decreases by the relative risk decreased by 0.558 when compared to women with insurance. Now, if you want to interpret based on their likelihood, you say you do 1 minus this, which you get 0.442, that is for 44.2%. So you say those without insurance prefer are 44.2 less likely to prefer private hospital to home when compared to those with insurance. Those without insurance are 44.2% less likely to prefer private hospital to home when compared to those with insurance. So with insurance means insurance equal to yes. So let me see how I interpret. The relative risks of those without health insurance preferring private hospital to home is this to those with health insurance. Women without health insurance are 6.2% less likely to prefer private hospital over home than those with health insurance. Exactly what I said. So let's try another one. So you also do that for education. For education, the reference level is higher education. I mean, talking about education after secondary school. So those we are comparing those with no education and those with higher education. We'll compare those with primary education with those with higher education. We'll compare those with secondary education and those with higher education. So now look at them. It means look at the negative, negative, negative. It means comparing higher education with all of them has a negative sign. Then all these two, they are also less than 1. They are all less than 1. So you do 1 minus this to get the percentage, 1 minus this to get the percentage, and 1 minus this to get the percentage. So let me show you. So I interpreted the 3 together. So look at how I interpreted the 3 together. So the relative risks of women with no education, primary and secondary education, preferring, remember we're doing private hospital to home delivery, is expected to decrease by this, and this respectively. You can do it one after the other, but why do it? To me, I prefer doing them together. So I prefer taking the 3 education because I'm comparing the 3 education level to higher education. So I prefer taking them at once. Then I will state it. I will state the relative risks at once and put respectively. So the relative risks of women with no education, primary and secondary education, preferring private hospital to home delivery is expected to decrease by this 0.058, 0.144, and 0.290 respectively, given that the other variables in the model are held constant. Now, interpreting it based on the likelihood method, we say this means that women in these categories now, you use your own words, don't follow me, or you can continue. This means that women with no education, primary and secondary education, are less likely than their higher education counterparts to prefer private hospitals to home delivery. So now what is this result showing us? Remember, after every work, you are supposed to make a recommendation and it's supposed to be used for decision making and policy making. So it's trying to tell us that those that have gone to school, they will keep on giving birth to private hospital when compared to if they have 2 options to choose between private and home. So they will always go for private hospital. But when you look at those with no education, primary and secondary education, there's a tendency and there's a possibility that they will want to give birth at home at a certain stage. And if you look at the, okay, yeah, I didn't state the percentage, but you can also state it. You also state the 3%. So the first percentage that will be 94.2%. That will be 85.6%, and this other one will be 71%. So you can state it. If you discover that those with no education have a higher percentage of choosing home over a private hospital, so followed by those with primary education. So you discover that education has a role to play in women's choice of place of delivery. So that means they have to ensure, so you make recommendation, ensure that women are educated, that women, they don't drop out from school. Now, that means they don't need to wait till they get married before they educate them. No, they should ensure that while they are still young, all of them go to school, because we discover that if they go to school, they will end up giving birth at private hospital, and they will reduce maternity and maternity death rate and infant death rate. So you see how the importance of this research work. This data is from NDHS, Nigerian Demographic Health Survey. So you also do the same for the next variable. That's how you keep on interpreting. So for this next variable, you do the same. They are all significant. So you compare north central to, we are comparing all the other regions to southwest. So look at how what I normally do. I will interpret all the ones that have negative together. So I will interpret north central, northeast, northwest, and south together. And I will compare the 4 of them to southwest. Then I will compare southeast to southwest. Why did I separate southeast? Because southeast here is positive, is 1 point. So I have to take the 4 that are negative first before taking. So look at how I interpreted it here. So pregnant women from north central, northeast, northwest, and south. I took the 4 first. Then in this place, I didn't talk about, I just went straight to using the likelihood method. Your choice. Interpret a research work is your choice. So I went straight to using the likelihood method. I didn't talk about relative risks. I didn't talk about odds. So I just went straight. Since I know that the one that is easier for people to understand is the likelihood method, so I went straight. Your choice, you use your pattern. So I just went to the percentage, calculated the percentage. So they are less likely to choose to give birth at a private hospital than at home when compared with their southwest. Then I remember I told you I was separated. Then I talked about the southeast. Those from southeast are 26.7. Look at this now, more likely. Why is it more likely? Because it's positive and it's greater than 1. So now how did I get this 26.7? When it is more likely, how do you get it? You subtract from 1. You subtract 1 from it. There is it. Southeast. What's the percentage? No. 26 point. Okay, look at it. I thought it. So look at it. You subtract 1 from it. So when you subtract 1 from it, you get this minus 1, you get 26.7. That is 0.267. Then multiply by 100 to get 26.7%. So that's how I got it. When you're talking about less likely, you subtract the value from 1. When you're talking about more likely, you subtract 1 from the value. Very simple. Then you multiply by 100. Let me say it again. When you're talking about more likely, you subtract 1 from the value. Less likely, you subtract the value from 1. That's what we've been doing. So when you have different levels, many levels, so you can take all the negative first, interpret them together, take all the positive and interpret together. So that's how I did for North Central. So I did same for the rest. Then I went to government hospital. And I also did same. So I interpreted it based on birth order. So let me just, don't need to explain much, but let me just show you. So birth order here is negative. So every unit increase in birth order. So I think, let me see if that mistake. No. I think I still made that same mistake here. Government hospital is supposed to come first. Over. So we are comparing government hospital against home delivery. So that's it. The same thing for everyone. A unit increase because a quantitative data. You interpret for education. You compare non-primary, secondary to higher education. They are all negative here. So you work with this. You can do 1 minus this to get the percentage. You talk about the region. Okay, look at the region now. They are all negative. So because they are all negative, I will interpret them together. So look at how I did it here. Pregnant women from North Central, Northeast, Northwest, Southeast, and South-South I interpreted everything together. Less likely to choose to give birth at a government hospital than at home when compared to those from Southwest. I seen it. But if you have positive and negative, you separate them, like I showed in the other part. So we are going to stop here for today. So I think the last topic will be ordinal logistic regression. So thank you for joining us. That means we're not going to end our class today. So I'll look for another time to share or to teach on ordinal logistic regression before we end the class. Thank you all for joining. God bless.